Hello students and welcome again to another science video. This one isn't actually a lesson that is detailed in your book, but is part of a lot of what you will need to learn in science. In particular, this will help you a lot with your performance tasks. Now, this is a review on experiment procedures and fair testing. This might be longer than what you would like to watch for something that is not specifically in your book, but this is your guide on how to conduct experiments and how to answer questions regarding your experiments. Let's begin. So, first off, when we say experiment procedures in science, we are, of course, talking about the scientific method. Now, very quickly, the scientific method follows these steps: the question, the hypothesis, the experiment itself, the results, the analysis, and then the conclusions. We will go over each of these one by one. I realize that you might already be familiar with this, but a quick review, a quick refresher might do everyone good. So let's begin. First off, the question or the aim. This is where the experiment itself will begin. This is what you are trying to find out. Now, you could pose this in the form of a question, or you could give this out as a statement. I will give examples later, but essentially, this is the point of doing the experiment. Next is your hypothesis. A hypothesis is a prediction, it's a guess. What do you think will happen? What do you think is the answer to the question that you just asked? Now, two very important things. Number one, because this is a prediction on the result, you have to give your hypothesis before you conduct the experiment. Number two, the hypothesis doesn't have to actually be correct at the end of your experiment. It's a guess. There's no way for you to get it 100% if you don't know the answer yet. The reason you're doing the experiment is because you don't know the answer. The important thing when giving a guess before an experiment is that you base your guess, you base your prediction, you base your hypothesis on scientific logic. You base it on what you have already learned. You base it on what you have already experienced on this topic. Don't just take a wild guess. You will take an educated, scientific guess. Next is the experiment itself. Here, try it out. Figure out what you need to figure out. Now, important to note here, be sure to record whatever it is that you're doing, whether through pictures, video, or simply writing things down. Remember, the only difference between science and messing around is writing things down. So keep a record. Next, the results. This, of course, is what happened after the experiment. Analysis. Why did that thing happen? And what did it prove? This is where you have your discussions, where you write or not. And lastly, conclusions. This is where you figure out if you answered the question at the beginning, if you reached your aim. Did you find out what you needed to find out? And whether or not your hypothesis was correct. If it was correct, good job. You learned well and you managed to put together the pieces of the puzzle that needed you to answer this question. If you were wrong, then you would need to go and re-examine what you learned. Why were you wrong? Was there something about the topic that you didn't quite understand? Or was there something in the experiment that you did not expect? So that, very briefly, is the scientific method. But I found that learning is always done best when there are examples. So we are going to use week seven's worksheet 2, the worksheet done in practice before the AA2. This is the laundry detergent thing. Okay, so let's apply the scientific method to how you had to conduct the laundry detergent experiment. First off, what was the question, or what was the aim of this experiment? The question was, does powdered laundry detergent dissolve faster in cold water or in hot water? Or if you were to phrase this differently in a way that is not a question, find out if laundry detergent dissolves faster in cold water or in hot water. As simple as that. Next, the hypothesis. What do you think? What's the guess? Well, I think powdered laundry detergent will dissolve faster in hot water. Now, this is not a wild guess. I'm using my own experiences and the things that I've learned and applying them into this hypothesis. Mainly, I sometimes like drinking instant coffee, and I know for a fact that instant coffee and sugar dissolves faster in hot water. Also, when I was younger, I liked drinking chocolate drinks, whether mixed in with water or with milk. Although I prefer to drink them cold, I knew to mix them with warm water first because it makes the powdered chocolate dissolve faster. And lastly, I have a daughter. I have a little baby girl, and I know from experience that mixing up her baby formula works better if the water is slightly warm. If you mix it in cold water, you will be shaking that bottle for a very, very long time. So I'm using my experience with dissolving solutes in warm solvent and knowing from that warm solvents work better than cold solvents. Let's move on. Next is the experiment itself. Let's do this. All right. So, what goes into this experiment? If you remember worksheet 2, here we go. First, we will need 2 containers. Next, we fill one of them with hot water, and then we fill up the other one with cold water. And then we add in equal amounts of powdered laundry detergent. And then we mix those together until each one dissolves completely. And while doing this, we time them. We need to figure out which one finishes first and then take note. And then we go to the results. What happened? Well, in the experiment that I did, the powdered laundry detergent dissolved in the hot water 2 minutes faster than in the cold water. So it took the cold water solution 2 minutes longer to dissolve the detergent. Now, if we were being truly scientific about this, doing the experiment once is not enough. Ideally, you will need to do that exact same experiment over and over and over, recording it each time, and then maybe taking the average time it takes for the detergent to dissolve. Remember, with experimentation and with science, being able to repeat the experiments and get the same results each time makes your results more reliable. Repeatability equals accuracy. Now, for the sake of time, and because this was a relatively simple experiment, we allowed you to do it just the one time. But for the record, if it was a real laboratory setting, or perhaps if this was an annual project of some sort, something big, we might need you to do the experiment over and over and over again. The exact same experiment. Now that we have our results, let us analyze why did the detergent dissolve faster in the hot water? Well, hot solvents dissolve solutes faster. I could go on with how energy is existing in warmer liquids and all of that, but it's outside of what the book tells us, and it's not really important for this. What is important in this case is that hot solvents or hot liquids dissolve solutes faster. That's the analysis. Next, the conclusion. Now, mister, aren't results and conclusions the same thing? Well, no. Remember, results is what came out of the experiment. Conclusion is the answer to the question at the beginning. And the question at the beginning was, does powdered laundry detergent dissolve faster in hot water or in cold water? And our conclusion is powdered laundry detergent dissolves faster in hot water than in cold water. The hypothesis was correct. Now, again, in an experiment setting, in this experiment, and in your AA, getting the hypothesis wrong is not a bad thing necessarily. You don't get a deduction for getting it wrong. You get a deduction if it was a wild guess, if it's not based on science, if your reasoning doesn't make sense. If you got it wrong, but you showed scientific reasoning, that's okay. All right? It's a guess. We can't expect you to get it right without doing the experiment first. So, hopefully that was clear. Now, before we end, let's get into the fair testing part of this presentation. In fair testing, it is all about the variables. Now, let's recall, what are variables? Variables are the elements that went into an experiment, all of the parts that went into it, all of the parts that you had to prepare, that you had to mix, that you had to burn, everything you needed to take record of. Those are variables. And how you treat variables will affect the experiment and will affect your conclusions. Now, there are 3 types of variables. Some of you might have forgotten this already. This was taught, I believe, since we're in grade 4. But let's review again. You have control variables, you have independent variables, and you have dependent variables. Let's take on them one by one. And again, using the detergent experiment as an example. Control variables. These are the parts of the experiment that you do not change. These are the variables that keep an experiment fair. These are the parts of the experiments that you are not testing, but they are the framework of what you are testing. In the case of worksheet 2, in the case of that experiment, we are talking about the size and shape of the containers. They have to be the same. You can't change it from one experiment to the other. The amount of water that you use in one experiment and in the other, they have to be the same. The type and amount of powdered laundry detergent that you used, they have to be the same. How strong or how vigorously or how energetically you mix the detergent into the water, it has to be the same. And lastly, you have to time them the same. Not meaning that they have to end at the same time, but you observe them within the same time frame. Those are your control variables. These variables cannot change in order to keep the experiment fair. Now, independent variables is where things get interesting. These are the parts of the experiments that you change on purpose. These are the things that you are actually testing. These are the parts of the experiment that will determine the results of the experiment. So, if all of these things, all of these variables in the experiment are control, What then are your independent variables? What do we change? Well, we change the temperature of the water. One has hot water in it, one has cold water in it. They're the same amount. The detergents are the same, the containers are the same, mixing them are the same. But the temperature of the water do not remain the same. One is different from the other. Now, why can't we change the amount of water? Why can't we change the amount of detergent? Because that would affect the result. If you gave one more detergent than the other, then of course that one would take longer to dissolve. If you gave one more water than the other, then the one with more water would likely dissolve the solute faster. So do not change any of those things. For this experiment, we only changed the temperature because the question is, would it dissolve faster in hot water or in cold water? Now, if the question had been, would powdered laundry detergent dissolve in a lot of water or in very little water? In that case, the thing we change is the amount of water. Then the temperatures have to remain the same, and so on. Lastly, the dependent variables. The dependent variables are your results. These are the changes that happened because of the independent variable. This is the result of using hot water versus cold water. So, in the case of this experiment, the dependent variable, the result of this experiment, is that hot water dissolved its detergent first. I hope that's clear. I hope this has been helpful. Until next time.